Today in college algebra, we start graphing the last two trig functions, tangent and cotangent. But in order to understand these two functions better, we're going to go back and look at our unit circle from our semester 2 formula sheet. Here's our unit circle. So, generally, when we looked at the first four trig functions, sine, cosine, cosecant, and secant, we started at 0 pi, we went all the way around our unit circle, and ended back up at 2 pi. Because the period for all four of those was 2 pi. The problem is, now that we're looking at tangent, if we started at 0 and went up to pi over 2, we'd run into a problem. Because at pi over 2, if tangent is sine over cosine, sine is y, cosine is 0, and 1 divided by 0 is undefined. So we'd run into a problem because that point on our graph would be undefined. You couldn't pass through it. All right? Now, the solution is we're going to actually go backwards in our graph. If we go backwards on our unit circle, instead of 3 pi over 2, this is negative pi over 2. Okay, and here we again have sine over cosine is negative 1 divided by 0, which is undefined. So our graph for tangent is going to be this part of the unit circle, okay, between negative pi over 2 and positive pi over 2. It's only going to be half of the unit circle. That is one period of the graph. Because at these two spots, we're going to have asymptotes. Okay? So, let's go back and look at what that means. So, here we go. At negative pi over 2, our graph is going to be undefined. Gotta get okay, we just saw that in the unit circle. At negative pi over 4, you have negative root 2 over 2 divided by positive root 2 over 2, which is negative 1. At 0, your tangent is 0 divided by 1, which is 0. At pi over 4, you have root 2 over 2 divided by root 2 over 2, which is positive 1. And at pi over 2, you again have undefined. So this is what it looks like for our points. We have a point at 0, 0. The point at pi over 4, which we're going to make here, and 1. We have a point at negative 1 and negative pi over 4, which is what we're going to make here. And we're going to have a asymptote at pi over 2 and at negative pi over 2. Okay, so your graph is going to look like this. Now, for tangent graphs, we're going to repeat this pattern over and over and over again as we go on both left and right of our initial graph. Okay, so it's a repeating pattern. It just looks like this over and over again on the left and the right. But we are only looking at one period of the graph, and one period of the graph is just this picture. Okay, so there's some important things to notice here. All right, what is the amplitude of the graph? Well, the amplitude is the distance between the middle point at 0, 0, and the other 2 points, which are 1, higher than 0, 0, or lower. Okay, so the amplitude of this is 1. If we change the amplitude of our tangent graph, that means those points are just higher above or below that 0, 0 point. Okay, and then what is the period? The period is 1 pi. Okay, and that is because the distance between negative pi over 2 and positive pi over 2 is 1 pi long. Okay, so unlike sine, cosine, secant, and cosecant, the period of a tangent graph is 1 pi, not 2 pi. Okay, so that's going to be an important piece as we look into the equations. Okay, now everything else about these equations works the same. Okay, it's no different than what we've seen in the past. So period changes work the same way. It's just they're looking at a different period. Length, vertical shifts, horizontal shifts, amplitude changes, all of those things work the same on tangent and cotangent. It's just those graphs look significantly different. Okay, so let's check this out. The same 4 rules apply. The first rule that we've looked at before and how to graph all of our 4 trig functions before tangent is step 1, find the period and the period intervals. Well, for this graph, the period does not change because x is not being multiplied or divided by any terms. Okay, so our period is going to be pi because it's a tangent graph. Okay, so what we're going to do for this is we're going to divide it in half. Half of it goes on the right side of the y-axis, so this is pi over 2, because that's half of pi. Half of this is pi over 4. On the other side, we have the same thing, but it's negative. This is going to be negative pi over 4 and negative pi over 2. So those are our intervals. Automatically, we can put to... Actually, no, I lied. Don't do that. Whatever I said, stop. All right, next, step 2. Find the horizontal shifts. Our horizontal shift is found right here. We're going to the right by pi over 2. So how many intervals is that? If we look at our graph down here at our intervals for our period, pi over 2 is 1, 2 intervals from the y-axis. So we're going to add 2 intervals going to the right. Okay, you're just counting. This is 1 over 2, 1 over 4. 1 over 4. This is 2 over 4, which means this is 3 pi over 4, and this is 4 pi over 4. And 4 pi over 4, although I didn't do it, I am going to. 4 pi over 4 is reduced to be just pi. So now our whole graph has been shifted 2 intervals to the right. Okay. What that means for our graph is our asymptotes for our normal graph, which were usually at negative pi over 2 and positive pi over 2, have also shifted 2 intervals to the right. So they are going to be now here at 0 and here at pi. So we can put those in after we've done our horizontal shift. Next, we have to find the first point. Well, tangent starts at 0. That's the first middle point. That's the point you can think of as the first point normally. So we have 0 plus 2. So your graph's going to start at 2. It's going to go up to the right by 1 and down to the left by 1. All right, and then we can draw our graph. And that's it. Let's look at our second example. We have negative tangent of x over 4. So again, step 1, take our equation of x over 4 and do the period change, because x is being divided by 4. There is going to be a period change. So we have x over 4 equals pi. Remember, it's pi because the period for tangent is pi, not 2 pi, like the other 4 trig functions we've used. But how you solve this is still the same. We're going to multiply by 4 on both sides. So our period is now 4 pi. So just like before, we have to divide our period into 2 pieces, the front and the back. So half of 4 is 2 pi. So we're going to put that here. Half of 2 is 1. On the other side, you have negative pi and negative 2 pi. This is still 4 pi long. From negative 2 to positive 2 is still 4 pi long total. Okay. Next, horizontal shifts. There are none. Nothing is being added or subtracted inside the parentheses, so there's no horizontal shifts, which means we can put our asymptotes at the front and the back of the period. Find the first point. Well, tangent starts at 0, okay, with a negative sign out in front, but that doesn't change where that point is. It's still going to be at 0. But that negative sign is going to flip the graph upside down. Normally it goes up and to the right. Now it's going to go down and to the right and up and to the left. It's basically been flipped upside down. And then we graph our points. Okay, and that is tangent. Okay. So, next we look at cotangent. So, for cotangent, let's go back to our unit circle and look at what's going on with this to try and explain this. So cotangent has some of the same problems as tangent did because of the way it works with the points. Let's erase all this stuff real quick. All right. For cotangent, though, we have a different set of circumstances. Now, at pi over 2, there is no... Oops, missed a spot. There is no undefined because cotangent is cosine over sine. And at pi over 2, Cosine over sine is x over y, which is 0 divided by 1, which is still just 0. All right, the problem lies in the fact that now at 0, pi, here, and at pi, now we run into undefined because cosine over sine is 1 divided by 0, which is undefined. And then same thing over here. Negative 1 divided by 0 is undefined. So your cotangent is going to go from 0 to pi, from asymptote to asymptote. Okay? So it's going to use the top half of the unit circle. All right, we're not going to go, that is one period of the graph because it has the asymptotes on either sides. So if we go back to our notes, we look at cotangent. All right, at 0, cotangent is going to be 1 divided by 0, which is undefined. Oops. At pi over 4, cotangent is root 2 over 2 divided by root 2 over 2, which is 1. At pi over 2, you have 0 divided by 1, which is 0. At 3 pi over 4, you have negative root 2 over 2 divided by positive root 2 over 2, which is negative 1. And for pi, you have undefined. Okay? So here's how this works. All right, at 0, the period is still pi, so we're going to go with pi over here. We have pi over 2, pi over 4, and 3 pi over 4. Okay, so our asymptotes are going to be here on the y-axis at 0 and at pi. Our points, at pi over 2, we're going to be at 0. At pi over 4, we're going to be at positive 1. And 3 pi over 4, we're going to be at negative 1. So this is what your graph. It looks basically the reverse of the tangent graph. Okay, so they can be a little bit confusing. All right, so it's the reverse of the tangent graph, but it's on a different point on the x-axis because of the way the unit circle works. Okay, so now let's look at some examples of cotangent graphs. All right, actually I lied before we get to that. What's the amplitude of this graph? The same one as before. For the tangent, it is 1. Okay, what is the period? It is still pi. So the cotangent and tangent both have a period of pi and a default amplitude of 1. All right, so let's look at these. Again, we start with the same steps. Find the period and the intervals. So we have 2x is equal to pi, because pi is the period for a cotangent graph. We're going to divide both sides by 2, and we're going to get x is equal to pi over 2. So we're going to have pi over 2 at the end. Pi over 4 is half of pi over 2. Half of that is pi over 8. And 3 times pi over 8 is 3 pi over 8. Okay. Next, we do the horizontal shifts. There are none. Nothing is being added or subtracted inside the parentheses. So that means we can put our asymptotes at the beginning and the end of our period. Okay. Cotangent, just like tangent, starts at 0. And then we have minus 2 as our first point. So the first point is going to be right in the middle of the two asymptotes, but down 2. And then the other 2 points are up to the left and down to the right. There we go. There is your cotangent graph. Okay, lastly, number 6 here, our period. Nothing changes on the period because nothing is being multiplied or divided by the x value. So our period intervals are going to be at pi, pi over 2, pi over 4, and 3 pi over 4. Okay. Step 2, the horizontal shift. We're going to the left by pi over 4. Pi over 4 is one interval in our graph, so we're going to go to the left by one interval. So this is going to be negative pi over 4. Okay. Which means our asymptotes will change to be here at negative pi over 4 and at positive 3 pi over 4. Because the asymptote moved over by one interval. So it's not at pi anymore. All right, find the first point. Cotangent starts at 0 plus 3 for that vertical shift. So the first point is usually at pi over 2, but it got moved over based on the horizontal shift, interval to the left. It's going to start up by 3. One up to the right, one down to the, one up to the left, one down to the right. My apologies. And graph your equation. And there is cotangent. All right, so please practice cotangent and tangent. These are the two that I think many people find the most difficult because they are a little bit different than the other 4 trig functions. So practice these. Ask questions if you need